My name's Tobias Falter, and I'm the environmental scientist for the Urey 5. For our mission project, our team will be investigating two main locations, TRAPPIST-1 and our own solar system. Based on the spacecraft's ability to jump in time, we determined it should also be able to jump in space to account for stellar and planetary movement. Even so, we will only be doing one or two jumps to avoid losing precious mission time. The first location, TRAPPIST-1, is a Class M red dwarf star with 7 known planets, labeled B through H. 3 of these planets, E, F, and G, are thought to be in the star's habitable zone, while all 7 are thought to contain large amounts of water in various forms. Planets around red dwarfs have often been thought to be uninhabitable due to the increased radiation and stellar winds which could rip away a planet's atmosphere. However, based on a paper published this August, it appears that in red dwarfs, the vast majority of the stellar activity is projected out of the polar regions and away from the planetary plane, keeping the planet safe. With an estimated age of 7.6 billion years, this leaves plenty of time for life to have formed on one or more of these planets. While chances of finding life may still be slim, the presence of water on the planets and the differences in environments will allow our members to explore the key questions: what role does bombardment by asteroids and comets play in making the planet habitable, as well as the question, what are the processes that result in habitable environments?
Titan's oceans are thought to be largely liquid water since its surface is mostly comprised of water and ice, which is plentiful on moons in the outer solar system. For example, on Earth, the gravitational attraction of the moon and sun tugging on our surfaces causes tides on Earth. Titan's interior has cooled substantially since its creation, which scientists estimate occurred approximately 4 billion years ago. Titan is also the only moon in the solar system known to have a significant atmosphere. The ultimate fate of Titan will be exploring its possibilities of liquid water oceans and hopefully evidence of life-building elements being produced in the atmosphere and seas.
My name is Adler and I am the engineer and videographer for the team Urey 5. My previous key question is, what is the fate of life of those on Earth? Through my extensive research, I found that this question is not very cohesive with the rest of my team. So I decided to explore other questions. The question that I eventually settled on is, do other planets or celestial objects host an aqueous environment conducive to early life, and is there evidence that life emerged? So the target environment that I'm looking at is Europa. Europa is the smallest of the 4 Galilean moons that orbit Jupiter. Europa has been proven to have an ocean buried under miles of ice. This ocean is so vast that it contains twice as much water as Earth, despite Europa being much smaller than Earth. I believe that if we have a mission that would explore Europa, we would most likely find organisms similar to that of Earth's hydrothermal vents, or the organisms around Earth's hydrothermal vents. This is because tidal forces could generate heat that melt Europa's mantle, and magma could seep through small cracks in this rocky material of the mantle and erupt on the seafloor of Europa's ocean, causing an environment similar to Earth's hydrothermal vents.
For the team Urey 5, I am the measurement scientist. My previous question that I was researching was the possibility of oceans elsewhere in the solar system. This is really important because, as you know, Earth and the life on Earth pretty much began in the oceans. And another celestial object that has a really high possibility of ocean would be Enceladus, which is the moon of Saturn. It is also known as the ocean world, and for a long time it had scientists questioning, why that object was so bright in the night sky. The Cassini mission found that the icy material that was ejected from the object, the moon, was actually high pressure water vapor from the subsurface of the moon. This was due to vents connected to a deep network of subsurface saltwater activated by hydrothermal vents. With the materials and the instruments, were given an opportunity and granted the possibility to explore this unknown territory. And I believe that ocean there would be amazing, because it would only lead to more possibilities of places to move to after the Earth eventually succumbs to pollution. Some scientists believe that in between the rocky core and the icy crust, that there's a global ocean that surrounds the entire moon. Hydrothermal activity would be important because it would mean that life could form on that moon, given access to something to supply, energy with, or to make energy from. Life can form in different ways. And that's pretty much why we're gonna explore Enceladus as one of our points.
Hello, my name is Curtis McMaster, and I am also part of the Urey 5. The last location our team has chosen for our mission is Mars. Mars is the closest planet out of the 5 choices, and one of the most researched already, making it easy to identify exactly what we would want to research on Mars and where. Some of the reasons we would want to research Mars in the first place is how Mars was a part of the late heavy bombardment, and recently liquid water flows were discovered on Mars. And these 2 things would help answer some of our key questions, such as what role does bombardment by asteroids and comets play in making a planet habitable, and are there oceans elsewhere in the solar system? If we are able to research these 2 things on Mars, we may be able to possibly answer these questions. Thank you.